Good afternoon everyone. This video we are going to discuss about signal flow graphs. So the graphical representation of the system is signal flow graphs. So normally here we are going to discuss about some of the points about the nodes as well as branch transmittance. So what is a node? A node is a point representing variable or signal. Okay, the point we are going to say here as a node over there. So example here, this is the node 1 2. Okay, so this will be the gain, and as well as transmittance, all those things we are going to call like this. Okay, so then comes into the branch. A branch is a reflected line, a segment joining two nodes. That means the line is connected between node 1 to 2, no, so that is called it as branch. The ear of the branch indicates the direction of signal flow from the gain of the branch or transmittance. So here from x1 to x2 the line is called it as branch. So the signal, the symbol, it will be shows from here to, that means the transmittance, the signal transmittance from x1 to x2, so that the signal flow from x1 to x2. That is the meaning of this one. Okay, so this is about branch. Transmitters, the gain occurred by the signal when it travels from one node to another is called transmitters. The transmitters can be real or complex. The gain occurred is called it as transmittance over there. Then comes into the input node. So input node only it will be sense the signals. Okay, that is called as input node. Output node, it going to receive the signal. Okay, that is output node. So here input node also called as outgoing branches. Only it have outgoing branches. Okay, see, check over in this diagram. Okay, uh, okay, so there are three nodes are there, x1 x2 x3. So x1 node, it will be sense the input branch, output branch, and x2 x3 node only it will be receives the output input branch. Okay, and the x2 node, it will be going to receive the output branch as well as it sends the uh, input signal as well as output signal. Okay, so that is called it as mixed node. Okay, so input node only outgoing branches, and output node incoming branches. Mixed node both incoming as well as outgoing branches. What is path? A path is a transactional of connected branches in the uh, direction of branch arrows. The path should not cross a node more than once. Okay, so that means from one node to another node, okay, up to input to output, the branches it will be connected, no, so that is called it as path. Okay, so here the open path, one open path starts at one node and ends at another node is called it as open path. Okay, closed path, it starts and ends same node, means that is in the closed path. Forward path, it will be the paths from input node to output node. Okay, does not cross any node more than once. Okay, that is called it as forward path. That means there is no repeated node, it will be take, or the rest branch should not meet at the same node again. Okay, if meet same node again means that is a individual path. Okay, forward path means from left to right. The branch should not travel same node again. Individual loop, so it is the closed path starting from a node, and after passing through a certain path, graph arrives the same node without crossing any node more than once. Okay, so individual path means starting the same node again it will be ends the uh, say starting from one node again it will be ends the same node, means that is called it as individual path. Okay, then comes into the loop gain. It is the product of branch transmittance of a loop. Okay, that is called it as loop gain. That means overall gain or gain of the particular nodes. So that is called as loop gain. Then non-touching loops. So whichever loop, individual loop does not touch in the uh, paths. Okay, so that is called as non-touching loops. uh, that loops not have any common node. So normally this non-touching loop, it comes in the individual loops. Okay, which are the two individual loops is not touching, means that is non-touching loops. Signal flow algebra. The signal flow graph for a system can be reduced to obtain the transfer function of the system using following rules. The guidelines developing the rules for signal flow graph algebra is that signal at a node is given sum of incoming signals. That is, we can see over from this rule. Incoming signal. So if we check over here, x1 x2 is the node. So incoming signal of node through branch is given and the produce the signal previous node and the gain of the branch. Okay, so here they are given as a x1 x2. Okay, so what is the output? X2 value is equal to a into x1. That is the thing they are showing. If you take down like this manner, if you arrange it, means x1 x3, x1 is the input node, x3 is the output node, another input node is the for x3 is the x2. So that this will become auto, right? A1 x1 so plus a2 into x2. So like this we have to write this like a paths. Okay, so what is the output? The gain into input. So here gain into input, gain into input. So these two things connected in the parallel manner, so we are going to add over here. Okay, then comes into the rule. Cascaded branches can be combined to give single branch whose transmittance is equal to the produce the individual branch transmittance. That means these two gain will be connected in the series, so we are going to multiply, that's it. So x1 x2, this x2 node we could eliminate over there, so it will becomes as a into b. Then comes into the parallel branches may be represented the single branch whose transmittance is the sum of individual branch transmittance. See x1 x2, so a and b are connected in the parallel. Okay, see direction also towards right, so that it will be connected in the parallel. So we are going to add over these two gains. That's it. That is the thing they are saying over here. Then comes into the mixed node. So here we are going to eliminate this mixed node. Instead of that, they are going to directly connect over here. Means what to do? A plus a and this a and c are connected in the series manner. So x1 into a into c and x2 x4 eliminating the x3 loop b into c. That's what they are showing over here. X1 is equal x4 is equal to ac into x1, here x4 is equal to bc into x2. So that means this gain transmitter is going to be multiply. Okay, so b into c is connected in the series, so b into c multiply over that to eliminating the mixed node. Then comes into the last one. So here it will require some derivations. So x1 x2 x3 nodes are there. So forward path x1 to x2 to x3, so this is the forward path. Reverse path x3 to x2, so this c transmittance is the reverse path. So a loop may be eliminated writing equation the input and output node and rearranging the equation to find the ratio of output to input. This ratio gives the gain resultant branches. So if we are eliminating this x2 and reverse loop, this equation it will become x1 into ab by 1 minus bc to x3. So this will be x1 x2 b by 1 minus bc. So how these values it will come, we will check in the next one. So here x2, what is the x2 value? A x1 into c into x3 plus. Okay, so a x1 plus c into x3 and x3 what is the x3 value? X3 value is here. What is the, this is the output, so b into x2, so that is the x3 value. Okay, so x1 x3, so x3 value b into x2, so x2 value you can substitute into the here, b into x1 plus cx3. So this equation it become bax1 plus bcx3. So x3 minus bcx3 is equal to bax1. So x3 into 1 minus bc is equal to bax1. So x3 by x1 is equal to ab by 1 minus bc. So like this way we can derive this value over here, because of output is the x3, input is the x1. That's what x3 by x1 it will become ab by 1 minus bc. So here output per transfer function x3 by x1 is equal to ab by 1 minus bc. Finally we can arrive like this. So like this way we are going to solve this one. So with the use of the signal flow graph and rules, we are going to solve some problem in the next PPT. Thank you.